All right, welcome back everybody. Uh, in the previous one we were building our RC car, and what we basically did was we didn't really build a car or a controller just yet. We just had two ESP32s that could communicate over ESP-NOW, so that could send messages which were pretty with arbitrary data, so that's quite cool. It's very extensible. But today I want to start to build some actual hardware, and I will start with a controller, and it looks something like this. I created this little controller. It's very close to what we did before. Before we did something with a Rotary controller a few episodes back. It's gonna be pretty much in that same vein, but we need to do some more stuff. So basically here, we have an ESP32 microcontroller, and we have a Rotary controller, and we have another Rotary controller. They are wired to different pins I don't know by heart, and you can just turn those, and you can press them as a button if you want, and that's it. And what we need to do now is to catch those signals and turn them into an ESP-NOW message and send it to our car ESP32 controller. So let's get started. Well, the hardware is not very interesting at this particular moment in time. So where we ended up in the controller was that we had a task that would send over and over every second 10 messages with a certain steering position from 0 to 10. What the steering position actually is, not quite defined yet, but it's a I32 type, so I can imagine that negative is left and positive is right, something like that, and that will determine the position of the steering wheel in a way. So this we need to extend. So let's start simple and have a look at our repository we made before a few episodes back. If you really want to get deep into the Rotary controllers, really look at the episode. I'll try to link it somewhere, because there we really went into it. So I think in that one we control the stepper motor. That's not interesting right now. It's basically this method. We have an encoder. We have two pins. We have two pins. In this case, GPO 4 and 5. The way I wired this one, it's 4 and 6, but we will fix it. And you create a Rotary object. That's a third-party library. And basically what we're going to do is we use Embassy to wait until something changes. So one of the pins change state from high to low or low to high. And then we read what that state is. And then we give that... and then we ask the Rotary object to determine which way it turned. So it has, like, if we call the pins A and B, then if you're turning one way, it says AB, 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 and otherwise it BA, BA, BA. And those states overlap a little bit, so it can tell which way it was rotating. So that's basically what that does. And then we have a direction, so that means that we did one step in clockwise, counterclockwise, or at closer investigation it didn't move at all. That can happen sometimes, so we just ignore those. And then we need to create a message from that to our ESP-NOW sender. So let's start with just copying this one, because I don't really want to do that again. And we'll just fix what needs fixing in our code where we left off. So a lot of imports to do. And as I said, it's not quite 4 and 5, it's 4 and pin 6. We need to add the dependency to the Rotary controller. There is an extra, a little bit of a snag there, and that is, let me check here. I needed to create a fork of it because oh no, that's not the one I had in mind. Let me check. Repository, something with Rotary. Yes. So I still need to make a pull request for that. But that, what happened here is that there were some updates that the embedded HAL that I need to use the one before that, I guess. Yeah, it used to use the alpha, and I had a release candidate, and trying to downgrade the release candidate back to the alpha to make this work was a bit of a rabbit hole. So I created this fork for the time being, but I guess as this new HAL version will be released, we can just go to the release version and be done with it. So to add that dependency, we will need to we can do it here. We can add the Rotary, and it's a Git version, and what was it? I think something like this. And then we needed to add a feature, I think. That's wrong. And we need to say a revision, I suppose. Revision. Let's get back here. And get this. Get this one. And there was something else which I thought I needed to do. Oh yeah, and features. And that was the, let me check, embedded HAL RC. Let's see what its problem is. Expected the sequence. You are so right. And now is it Rotary encoder? Oh, the name is wrong. Alright, it seems to be building happily again. There's probably still things wrong here, but getting somewhere. Let's see. Okay, so now we it still doesn't really seem to actually build anything. Ah, there we go. Let's import the rest. Is there already something? Or did I put it in the wrong? Oh. Where did I put it? Confused now. It seemed to have vanished. Let's see. Ah, there it is. I don't know what happened there. That's some VS Code magic. Let's see if we can import now. It's taking its sweet time. So yeah, as long as we are waiting here. So I need to remove this part. Something happened. Let's see. Can it import now? It looks like it just timed out. Why is it not? I think it's time to restart VS Code again. Yeah, about here. Sorry for the slightly boring video. Edit something, see if it starts doing something. Okay, now the error is back at least, so it's doing something. And now I'm trying to import it, and at times, yeah, usually it's fine, but not right now. Yeah, here we go. It woke up. I don't know what that was all about. So let's import the other thing. So the select. So what the select does is that you can basically wait for two different events at the same time, and that it will just trigger whenever one of the two happens, which is really useful for a situation like here with the Rotary encoder, because that will, you have to watch two pins at the same time. This is all not interesting. I'm going to remove it. So right now we have an encoder that will listen to those pins. What we should do then is pass that sender we had before, the ESP-NOW sender, also to that method. And then we can just we can just create a message. It was a control message, yes, of steering position with a value of count, and we can just serialize that 2 bytes, and that's something we can send over the wire. So we can do then sender.send async to the broadcast address, reference I think. And the data is that thing we just constructed here. And I think that needs to be a reference as well, yeah. And then we need to await it. And probably unwrap something, yeah. So now we have an encoder, and whenever we turn it, then it will send a message. We need to still invoke it. So this one we're gonna remove. Encoder. We have the sender, but we also need to supply the pins. Did we have I/O? Yes. We used I/O. we say io.pins dot pin GP. Is this not the way? Yeah, GPIO, yeah, GPIO4 and io.pins.gpio6. And then we still need to, I'm doing something weird. They shouldn't be here. They should be here. And then we still need to convert them into input pin, into pull up input, I think. So that actually means that that the pull up is that you connect a really a large resistor actually, that if nothing is connected to it, as is the case normally with a rotary encoder, if you don't touch it, then it will be high, and whenever something connected, it's low. But otherwise it will be in the floating state. And I think this needs an await to make this work. Okay, now we have, we're calling that one. This one is no longer used. Oh. So we can remove that. Yeah, some warnings. And it will also print something so we can see if it's working. Let's see, I had the controller up here. So we're gonna, let's add let's flash it. Yeah, this one. There is something wrong. Oh, I somehow missed that there was an error there. I forgot the annotation task. So that's yeah, I guess that was it. So it should, I didn't need a await, I just needed the task annotation, because as a top level task it's really something else, than it's not a method per se, it's just a top level task. Okay, so that one is running. Let me see if I turn it. And then you see, if I turn one way, it goes up. Other way, it goes down. Now for the other controller. So this is, remember from before, we had the car controller. That is this port. That's the one that's gonna listen to the messages. So we are not touching that one, but it should pick up the messages we had, we are sending. It's now reflashing, but it's actually that side of the code hasn't changed. Alrighty, so it says receive. Oh, you can't see. Oh, wait. So if I turn it now, then it receives the control messages. This one was the sending one that just did the print, and the other, I guess, did the info. So now we actually created a physical controller that we can listen to. We do have some things to improve though. Let me remove the camera. So this task, the encoder, that takes the sender object. And the sender object is what's sending, which is fine in this case, but I only have one of those. So right now here I create a sender from the ESP-NOW, starting it up and configuring it, but I can only make one task and pass it onto it. So that would be tricky, right? Because right now we only had one rotary. We at least have another one. We might figure out other buttons or other inputs, and that would imply that we all had to cram it into the same task. And that's going to be tricky, and that's also not the way it's supposed to go. Because what I would want, and what's kind of the point in my opinion, is to really make it extensible, that if you want to make a switch to switch on the headlights on or off or something like that, that it's just something you add and you don't really need to touch the steering code for that. So that's not is not perfect. So what I would like to do is to use some of the primitives from Embassy, and that are the channels. We used the channels before, but what I would like to do now, I would like to have a look at the PubSub channel, and that's different to a channel, different to a regular channel, in the sense that in a regular channel you could have multiple producers. You could technically also have multiple receivers, but every message would go to one. So you could use that for some kind of splitting of the load of something like that, that you pump in messages on one side and there are several consumers on the other side and they divide the work amongst them. But in this case, that's not what we want. We just want to make sure that everybody can send and receive on both sides from this kind of bus-like data structure. So let's make one of those. And that's a PubSub channel. So let's let command channel, something like that, equals PubSub channel new. That's not going to work out of the box because we need to add a lot of type information. So it's a PubSub channel. It needs 5 generic parameters. First is the mutex. As we are running on a single core, as far as I understand, tell me in the comments if I'm wrong, but it seems to work that I can always use a no-up raw mutex because there is only one thread. You have the type itself, so that's the type we defined in protocol. We have cap, that's the number of messages in flight maximum. So if for some reason the downstream is delayed, at some point the source will block, like back pressure. But as this is all kind of geared towards having a no alloc footprint, so that you can make sure that it doesn't need to allocate memory after it's initialized. By the way, that's not what I'm doing. I'm allocating all over the place, but that's how this library works. And also we need to define the maximum number of subscribers, the maximum number of publishers. Doesn't really matter that much for us right now. So let's just define something. PubSub channel, these things, the no-op raw mutex. What was it? Something control message. We had maximum in-flight messages, something like that. We can start here. However, it is really convenient to at least make it into some kind of constant, or I could make a type alias. I'll make some quick constants. Const max message I32 now usize, I think 10 const max publisher usize 5 const max subscriber usize 5. So we can use those because it actually matters, because every place we use this thing, it's part of the type, right? So we need, if we have one number different, it's just a different type, and that gets confusing. It was publisher subscriber, right? No, subscriber publisher. Doesn't really matter in this case, but here we go. Alright, so now we have the channel, and from that channel we can create a publisher as many as we want. Well, in this case up to 5, but we can increase that number, of course. And we can create subscribers, and that kind of ends up so you can pipe things together without having to resort to like write locks and shared mutable data. So I think that's a much nicer model here. So instead of the sender, I'm gonna give it a publisher from this channel. Oops. Command channel and a publisher. And wrap it, I think. Yeah. And then the sender is not a sender anymore, it's a publisher. And it's a publisher, this one, with all the I think the static still needs to be there. No up, raw mutex, control message, max, publisher, no, other way around, subscriber, max. Oh, I forgot the max message. Is this happy now? Ah, yeah. So, because I'm passing it into a task that will live forever, I can only pass things into it that also live forever. Sometimes it starts to choke on the macro here, so I generally do it like this, that I just recreate it basically. I reassign the immutable variable. So now the command channel is actually not the owned one, but it is a static mutable reference, and that should fix that part. Now we need to change this a little bit. Publisher, publish, well, this thingy. I'm not going to serialize it here, I'm just going to create a message. And I await it. And I probably, no, I don't need to unwrap it. And this I can remove. So if I were to run it now, it would work for exactly 10 times, because then the queue, the PubSubChannel is full, because nobody is reading it. So we will need to add a method that will read the contents, if that makes any sense. So what we're gonna do is make another task, even async function. We call it sender, and we pass in the ESP sender, let's call it that. ESP-NOW sender. I'm not sure if it had any other annotations, or just static, I suppose. And the other thing is we're going to pass in a subscriber from our channel. So that will be something like a subscriber. Need to give the name first. Subscriber. And that's gonna be basically the same things. It also needs a lifetime. And then we're gonna say the no up raw mutex, the control message, the max message, max subscriber, max publisher. Okay, so now we have that. And then basically what we can do is we loop. That's always the case in these things. To make it nice, I like to indicate that it can never return. And then we listen to the subscriber. So we say, what was it? Let's remove this one. I think we need to have next message pure. If you use the next message, it can also indicate that messages were lost, because in some cases it can overflow. In that case I would ignore it anyway, because what else can I do? So I'm going to use pure because it's a little bit simpler to use, and I just await it. So now I have a message, that's a control message. And then I simply take my ESP sender, I send async to the broadcast address, the data I had before, so that will be a serialized version of the message. So that's message.2 bytes, and then reference it and await it. Need to be mutable, both of them I suppose. Yeah, so mutable subscriber and a mutable ESP sender. And now it's nearly happy. I just need to unwrap it. Alright, so we have a task that specifically just monitors that pipeline, and whenever something comes out it sends it over ESP-NOW. And now we have the advantage that we can make as many of these tasks as we want. Well, up to 5, unless we increase that number. It will basically just work. So we need to still instantiate it. So sender, let's remove those. What was it called? The ESP sender. And what was the other one? We need to take the command channel and we create a subscriber. Why is it not working? That is weird. I'll just hammer it in and see what happens. And unwrap. It's weird that the autocomplete sometimes suddenly fails. It's important to have some confidence then and just keep going. Okay, so now I implemented that. Let's see if it actually works. So this was the our virtual car. So let's refresh it just for the sake of it. And this was our controller. And let's see, it should behave exactly the same, but now we can easily add things. And I think with that it's about long enough, I think. So then next time we'll move on to the actuators to have something on the car side. I was fooling around with the servo, but I kind of broke it, so I ordered a new one. But maybe it can still do something, so we can at least work on it. I ordered a lot of things. So let's see where we are now. Oh, I think I just touched the cable. The cable is super flaky. Yeah. This model has a micro USB cable. The other one has a USB-C, and that's so much better, USB-C. Alrighty, let's see what happens. So this still seems to work, and oh, this one wasn't flashed yet. But it's already a very good sign that I could do more than 10, because if that sender wouldn't work, that's how long it would take for the buffer to overflow, and then it crashes basically. I could deal with that more gracefully by dropping the last messages, something like that. That kind of makes sense, think about it. So this one's up and running, and if I move now, I get the position. So where does that leave us? So now we have this part. We can use one rotary. I would like to add the button as well, so you can press the control as well. That's a button press. So with this, what we have now, we have 2 buttons and 2 rotaries, so you could kind of control a car with that, at least for now. So I think then it's time to start working on the car. So I have some early attempt. So this is a 3D printed base chassis of a Belgian guy on Creative Electronics. It's easy to find, and that's 3D printed. So I printed all this. I added a brushless motor with a motor controller, which should control pretty much the same as a servo, so I don't really expect any problems there. I have some bearings in here, so this is like a regular bearing, and there need to be one on the other side as well, and some other support structures. So yeah, that's coming along fine. The servo needs to fit here in front on this side, so you can steer. Then some batteries. I ordered all of it, so it's on the way from Amazon. I'm a little bit apprehensive about batteries. Those powerful LiPo batteries, they terrify me a little bit. So right now I can afford to be messy with the electronics, and I know nobody will die, but I have to get a little bit more careful if I work with those batteries. So yeah, see you next time. Then we can look into the servo and motor, and hopefully soon we have something that actually does something. All right, take care guys, see you soon.